In this video, we're going to explore the process of creating an IO-style game in Highrise Studio. So first, we can create our new project through the Studio Hub, and let's use the basic template for this one. Now we can just delete the default assets we don't need and clear the nav mesh and lighting settings. The floor we can just make invisible by creating a new material that we set our alpha to 0. And for the background, I'm just going to go to the sky material and change the colors around until I find something I like. Now we can start scripting. I'm going to create a new Lua script called Player Manager, and I'm going to set this to be a module type script, which will be able to run on the client and the server. So we can start off with a client awake and a server awake function. Before we use those, I'm going to create a new function called track players, and this is going to connect to the event when a player joins a scene and then add that player to a table so we can store player information that we'll then be able to reference on the client and server. In our table, the player can be the key and the values can be a new table that stores the player and its network integer value. The network integer's network ID will be power concatenated with the player's ID, making sure that every player has a unique network integer value that they can store information in. Now we can connect to the player's character changed event, which will fire whenever the character changes, including when it's instantiated. Here we can create a new variable called player info, which will store the player's information from the player's table, so the player and its power value. And if our track players function gets a character callback parameter passed in, we'll call the callback and we'll pass player info as an argument to that function. Lastly, if a player leaves a scene, we'll remove them from the player's table. Now in the client awake, we can create a new function that'll be our character callback. We'll call it onCharacterInstantiate, and it'll take player info. And we can store the player, the character, and we can connect to the power changed event, since power is an integer value. At any point where the server changes the value, it'll fire this event to all clients. When we connect to the event, we get the new value as well as the old value, so we'll just have it print out the new value for testing. And now we'll just create a new event that we can fire from the client to the server just to test the value changing and make sure it's working as we expect it to. In the client awake, we can fire the event, and then in the server, we can connect to the event. When you connect to the event, it'll give you access to player, which will be the player from whichever client fired the event in the first place. So here we can create a new variable called local player info, and this will be the player info for this player. So we'll use this player as the key for our players table. Now we can change the power value from this player info, and we'll just set it to a random number between 1 and 10 for now. And if we run it a couple times, you can see that we get a random value between 1 and 10 every time we start the game. Now we can take our character and set its render scale to a new vector 3 based off the power value. And we can just add some math to clamp the new scale between 1 and 2. Now if we test the game and add in some extra avatar players and walk around, we can see that everyone pops in with a random scale. To start creating collectibles, we can just create a new sphere. We can give it a material with some emission, and then we can create a post-processing volume in our hierarchy to add some bloom. Back in our player manager script, we're just going to set the new power value to 0. That way the character stays at default size for now. Now just double checking some settings in the project, making sure we're on gamma space for coloring, adding an energy orb layer that we won't end up actually using, and then just creating some folders to sort the assets. Now we can go to our pickup object that we made and just add in some simple animations for an idle loop, as well as saving our object as a prefab. Now we can create a new script. This one will just be a client-side script that we can call energy orb script. Here we can require our player manager module getting access to any functions we've defined in there from our orb script. In the player manager module, we can add a new function called add energy, which will justify the existing event that changes the power of the player. Then in the energy orb script, we'll just call that function on the awake to make sure it works. Now instead of awake in our energy orb script, we're going to connect to the onTriggerEnter event, and we're just going to print triggered by and then the collider.gameObject.name to make sure it's working as we expect it to. Now to get the actual player that's colliding with the trigger, we can use getComponent to get the character component of the collider, and then we can get that character's player. And now we'll just print triggered by player.name. I only want these collectible by the local player, so we can do print player == client.localPlayer to tell if the collider is the local player or just an avatar from a different player. Now if the player that collided is in fact the local player, we can then call the add energy function from the player manager. And And when we test it, we can see every time we enter the trigger of the orb, we get set to a random power value between 1 and 10, which sets us to a random scale between 1 and 2. Now we can just rename our event from test event to add energy request, and rather than setting our power to a random power between 0 and 10, we'll just set it to our current power plus 1. Now back in our energy orb script, after the trigger is entered and the function is called, we can now destroy the orb. Here I'm just going in and adjusting the scale to power ratio until it's something that feels about right. Now we can make prefab variants on the world prefab and the player character prefab from the package. That way we can modify the player character that spawns into the scene. And in the player character prefab, we can add a child object that's going to be its trigger with a sphere collider, so we can detect when players collide with each other. This, however, creates a problem with the energy orbs detecting something entering its trigger that doesn't have a character component, so we just need to add a check into there to make sure it only fires if a character goes into its trigger. So on the pickups on trigger enter function, we can just do if the collider character is nil, then return and just ignore the rest of the script. Now we can create a new Lua script that we can call the character collision script to manage when players collide with each other, and we can just copy all of the code from the energy orb script and cut out what we don't need to get started. What we have left is the on trigger enter, and when a collider enters a trigger, if the collider has a character component, we save that in the character collider variable, and then we create a new variable called player, which is the character collider's player. And since this is a player-on-player detection, we need to store the player information for the one who owns the collider, and we need to store the player information for the one who owns the trigger. So in my character and my player, we'll store the information for the one who owns the trigger, and then collider character and collider player will be the player that entered the trigger. Now I'm just going to add some nil checks and a print to log in the console when a player enters another player's trigger, so we can make sure it's tracking correctly. And then when we test it, we see we get 4 prints in the console because both avatars on both clients are registering the event. So what we're going to do is we're going to add a trigger to make it so only the local client registers the trigger, And only the client that has the most power will fire the event to the server, making sure the server only gets one event. And when the event is fired to the server, it also provides the player argument, and that's just the player from the client that fired the event. So whichever player fires the add energy function is going to get the energy. And in our collision, whichever player has the most power is the one firing the functions, we can just get our player manager script module and add energy. And whichever player had the most power is going to fire the event and get an energy boost. And if we test it, every time we walk into an avatar with less energy, we just get bigger and bigger each time. So now we just need to go in and add a function to destroy the one we're consuming. Now in the player manager script, we can add a destroy player function and then a destroy player request and event for the server and client. And just like before, the event is being called by the client that won the collision, which isn't the player we want to destroy, so we're going to have to pass in an extra argument, which is going to be the victim. So when we call the event, we're going to have to pass in the player that we collided with to make sure we destroy the right one. Now back in our client awake, we can connect the destroy player event to locally destroy the player on all of the clients after the collision is handled. And by destroy player, all that means is we're going to reset their power level to 0 and then teleport their avatar back to the center of the stage. Later we'll switch that to random teleportation, but for now we're just going to set the position to 0, 0, 0. Back in the character collision script where we call the add energy function, we can now connect to our player manager script module and call the destroy player function and just pass in the collider player to pass in the player that lost. And to add in some variation to our energy orbs, we can connect its power level to its scale. So we're just going to pick a number between 1 and 10 when it spawns for its energy level, which is the amount of energy you'll get when you collect it. Then we can connect its scale to be 1/10 of its power level. That way bigger orbs give you more energy and smaller orbs give you less. And before I made the reset energy a separate event in request from the destroy player, which actually didn't make any sense. So I just removed that event in request and just moved the function into the same event as the destroy player. So when destroy player is called, it'll teleport the avatar and reset the energy just all at the same time. And here we have an issue where the avatar just keeps consistently growing while overlapping the smaller one, and that's because when the smaller one's destroyed, it keeps re-teleporting back to the center and then re-entering the trigger every time it teleports, so it's just a loop, which is exactly why we need to make it so the avatar is a random spawn location when they get destroyed. And now the last major piece we need is the energy spawner to spawn in the energy orbs throughout the map and keep them consistently at a high number so you can keep collecting them. So to start that, we'll create a new script called energy spawner. So we'll need spawn distance, which will be the radius of where they can spawn, and then we'll need an active orbs count to keep track of how many orbs we currently have on the scene. And then we're going to need to make sure we serialize a game object called energy orb so we can drop in our prefab so it knows what to spawn. And I want it to keep the energy orbs at around a specific number, so I'll have a max and a minimum count, and whenever it gets below the minimum, we'll have it spawn the difference in orbs to get it back up to the max. That way there's always a consistent number of orbs in the level. And to do that, in our update function, we can just check if the active amount of orbs is less than or equal to the minimum amount. The difference will be the maximum amount minus the active, and then for each one in that number, we can spawn a new orb, keeping it always between our minimum and maximum amount. Now in the energy orb itself, we're going to reference our spawner script. That way on start, when the orb is spawned, we can increase our energy count by 1 in the script to keep track of how many are in the scene. And the reason I'm updating the count in the energy orb script and not just in the for loop in the spawner is because in the energy orb script we need to update the count by -1 when it's destroyed anyway. So it's easier to just have the increase and decrease in the same script. And here we have an issue where the orbs are spawning in a straight diagonal line like this, and that's because when they spawn it creates a random number, then sets each coordinate to the same random number, so it confines them all to the same line. So we need to create a different random number for the X and then the Z, and then just have the Y be defaulted to 0. That way it randomizes its position on the flat plane. Now we can get rid of the serialized field for the energy in the orb script because you don't need to set it in the editor anymore since it's dynamically spawned. So when we spawn each orb, we can just individually set its power to a random number between 1 and 10. And now it's just adjusting the values we have, adding in some sound effects and particle effects, and generating a random number for the respawn rather than just using 000. And that's about everything that goes into making this kind of game. Thanks for watching, and if you haven't yet, go ahead and give the game a try. It's live in the app, and I'll see you guys in the next one.